Hey everyone, Ricardo here, and in this video I'm going to be showing you how to model protective relays using the ETAP software and how to run protection coordination studies. We're going to be modeling the relays in an example 230 kV to 13.8 kV substation, including an SEL-487E relay for transformer protection, an SEL-487B relay for bus differential protection, and two SEL-751 relays for feeder protection. We'll also perform the protection coordination study for coordinating the overcurrent elements in the SEL-487E transformer relay with the overcurrent elements in the SEL-751 feeder relays. But before we go over how to model protective relays using the ETAP software, make sure to subscribe to the channel. We always post videos here about power engineering and power system protection and control. And if you want to learn more about power system protection and control, check out our online courses where we go into these topics in a lot more detail. All right, so let's go into the ETAP model and let's see how we can model protective relays and how we can run protection coordination studies. All right, so here I have the blank substation without the relays. And again, here we're going to be modeling the relays for the transformer protection, the bus differential protection, and the feeder protection. And to be able to add relays to an ETAP model, you need to be in what's called the edit mode. So that's the view that I'm on right now. And this is where you can add devices to your model, such as protective relays. If you are in one of the study modules, you cannot add devices to the model. You can just run those studies. So to be able to add the relays, we need to go into the edit mode. And again, here I have a blank substation without the relays. So let me actually zoom in a little bit more. And the first thing that we're going to model is the transformer relays. And of course, here, the first thing that we need to do is to add the current transformers that we're going to use in our relays. So if you go over here to the right, you're going to see all the different devices that you can add into the model. Here, we're going to go to the current transformer. So that's here under instrumentation. And you can see over here that I have a current transformer. So I'm going to click and drag that into my model. And of course, that comes with a default of 0 to 5 CT ratio. The CT ratio for the high side CT for the transformer differential relay is 400 to 5. So you can just double click on that, go to rating, and here you can set the primary. In this case, it's going to be a 400 to 5 CT. So I'm going to go ahead and click OK over here. And before I put that into my model, I want to rotate this such that it's looking the other way. So I'm going to go here to rotate 180 degrees. And I also want the polarity. If you can notice over here, the polarity of the CT is looking up. I want that to be on the other side such that it looks down into the transformer. So I'm going to right click on that and select rotate reverse polarity. And so now that polarity is looking down. So now I'm going to place that into my model. I can just simply click and drag to the high side breaker on the incoming side. And that's the CT that I'm going to use for the high side CT for the transformer differential relay. I also want to place another CT down here at the main breaker, which is going to be my other CT for the transformer differential relay. So I can just make a copy of this, Control C, Control V, and then I can move this down. I want that to be down here on the main breaker. And here again, I want the polarity to be looking into the transformer because this is going to be for the transformer differential relay. So I can go back over here to rotate and unselect the reverse polarity. And so now the polarity of this CT is looking into the transformer. And the ratio for this is going to be 5,000 to 5. So I can change that over here, 5,000 to 5. And now I have my two CTs for the transformer differential relay. The last thing that I need to do, of course, is to add the transformer differential relay. So I can go over here to differential relay, click and drag. Let me actually rotate this as well. So I'm going to do rotate 180 degrees. And I'm going to feed my two CTs into the differential relay. And I'm going to call this my T1 relay. And for the display tag, let's just do SEL-487E. This is just something that shows up on the one line. So it just helps to have the model and the manufacturer for the relay. In this case, an SEL Schweitzer SEL-487E relay. And so you can see that I have my differential relay over here. Let me actually drag that to the left. And let's move these CTs just a little bit to the right so I can see the name of the relay. So I'm going to put that over here. And here I can go into the relay and then go to diff, go to library. And here I'm going to select the manufacturer and the model for the relay. In this case, again, I want a Schweitzer And then we can select over here 487E. And let's do this one, the 487E-3-4. That's the latest version of that relay. So I can click OK. And again, that's going to be a percentage differential type. The trip time or the operation time for the relay is by default set to 1 cycle, so roughly 0.02 seconds. And this basically sets the differential element, but we need to do a couple more things. First, let's go to input. And here's where we're going to add the CTs that we're going to use for the differential function. I can go over here where it says terminal, diff1, diff2, and I'm going to add my 2 CTs over here. This is the high side CT, 400 to 5, and the low side CT, 5000 to 5. So this tells the model of the relay in ETAP that these 2 CTs are the ones that I'm using for my differential function. And I'm also going to be implementing overcurrent elements using the high side CT. So I'm going to have a phase element that is using the 400 to 5 CT. And then the other thing that I want to do is go to output. And here's where we'll tell the relay which breakers in my model to trip when the relay operates. So I can set this logical tag DO1, and this is going to assert, so become a logical one, when any relay element within this relay operates. And then I'm going to set the output of that digital tag to trip 2 breakers. Of course, I want to trip my high side breaker. So T1 high side breaker and the main breaker on the low side of the transformer, which I called the M1 breaker. So again, just to summarize, what I did here is I modeled this relay as an SEL-487E relay. I enabled the differential function. I told it that the CTs that it's going to be using for the differential functions are the high side CT 400 to 5 and the low side CT this 5000 to 5. I also told it that when the relay element operates to go ahead and trip this high side breaker and this low side main breaker. And so that sets up the whole scheme where if we place a fault somewhere in this zone of protection, ETAP knows to trip this high side breaker and this low side breaker. All right, so now let's model our bus differential relay. So very similar. We're just going to add the CTs. We're going to have one over here on the main breaker on the incoming side. And then we're going to have 2 CTs, one here for feeder 1 and one over here for feeder 2. The one on the main breaker is going to have a 5000 to 5 ratio. So let's go ahead and set that. The 2 CTs on the feeder breakers are going to have 2000 to 5 ratios. So I'm going to set this to 2000 to 5. Same thing for this one. So let's go to rating, 2000 to 5. And then notice over here that the polarities of these CTs on the feeders are looking out into the feeder. That's of course not what I want. What I want is for my CTs to look into the bus, since this is going to be part of the bus differential scheme. So I want all the CTs involved to be looking into the bus. So let's go into these CTs. Let's right click on that, go to rotate, reverse polarity. And let's do the same thing for this one, rotate, reverse polarity. And now they're all 3. This one that we're going to be using for the main breaker and these 2 that we're going to be using for the feeder breakers. They're all looking into the transformer. So now I can add my relay. So I can just click and drag this 87 relay. I'm going to call this the bus relay. For the display tag, again, I'm just going to do the manufactured and the model. So SEL-487B. And let's connect the CTs over here. So one over here, another CT over here, and another CT over here. So I have my 3 CTs for my bus differential zone. And let me move these to the left a little bit so that I can see the name of the relay. And again, here we have to do the same thing. We can go into the relay, tell it which CTs to use for the diff function. Here we're going to have 3 CTs, so we can select CT terminals here to 3. We're going to have the high side CT, or rather the main breaker CT, the 5000 to 5 CT, and then the 2 feeder CTs, which are both 2000 to 5. And again, we can go over here to diff, go to library, go to Schweitzer, and select the 487B relay. Click OK. Again, we set the input. And actually, one thing that happened over here is that we should have done this part first, because when we select the relay type, then everything just kind of resets. So we just need to select this again. CT1, CT2, CT3. Again, these are going to be the main breaker CT and then the 2 feeder breakers CTs. And now we can go to output and we're going to do the same thing. So now we're going to have one digital tag and we're going to say when that operates, I want to trip 3 breakers. I want to trip the main breaker and the 2 feeder breakers. Notice here that, of course, we have the option to select the transformer high side breaker, but of course that's not what we want because we want to just trip the breakers surrounding the bus. So the F1 breaker, the F2 breaker, and the M1 breaker. So these 3 breakers, this one, and this one. So again, just to summarize, same thing that we did for the transformer, we modeled the relay, we selected the SEL-487B from the library, we set a protection element that is a differential element, and when that operates, it's going to trip these 3 breakers which surround the bus. And so that sets up the whole scheme. The last thing that we need to do, of course, is for our example to model the SEL-751 relays on the feeders. So again, same thing, we can click and drag the CTs. These are going to have the same ratio. So these are going to be 2005. Same thing for this one. Rating and 2005. We can select a multifunction relay now. Feed that CT into that. And let's go inside of here. I'm going to call this the feeder 1 relay. And again, for the tag, I'm just going to put the model of the relay. So SEL-751. I can go over here to OCR, go to library. And again, here we can select a Schweitzer SEL-751 for this case of the feeder breaker. So now that sets up basically what's available in this type of relay. And then again, we need to select, or at least make sure that the CT ratios are correct. So in this case, there's only one CT wired to the relay, so ETAP knows to just use that CT. So it's going to be CT5 for the phase and ground elements. And then later on, we're going to set these overcurrent elements. But again, same thing. We can go to output, add a digital tag, and in this case, when that operates, it's going to trip breaker F1, which is for this feeder. So I can click OK. And now let's go and make a copy of this one. I can move that over here. Let's put this back over here. And let's feed this CT over here. I'm going to rename this to feeder 2 relay. And then let's check everything else. The input, notice here that ETAP actually correctly moved this from CT5 to CT6 because it knows that that's the CT that's wired into this relay on feeder number 2. And then same thing for the output. We can go here to the digital tag. Let's add a trip output, and that's going to go now to the F2 breaker. And then lastly, let's go to OCR. And here we see that we have, again, a Schweitzer 751 relay. So let's go ahead and click OK. And so that's how you model a transformer relay, a bus differential relay, and feeder relays using ETAP. Now, the other thing that I want to do as part of this example is to show an example protection coordination study. So typically what you would do is go here to the star protection coordination module within ETAP. Click on that. You can select everything that you want to be included in a TCC, so a time current coordination curve. And then you can click this button over here, which is to create a star view. Now in this case, I've already created one. So I can go here to window and go to high side TCC, which is what I called this TCC. Now notice over here that I have all the devices. So the breakers, the transformer, the cable, all the CTs, but I don't have my relays in here. And that's because we just modeled those. So if we go back to the one line, again, what you can do from here is you can select what you want to include in the TCC. So in this case, I'm just going to implement an overcurrent element using this CT. That's going to be the backup overcurrent for the transformer. And then I'm going to coordinate that with the feeder relays. In this case, I'm not going to have an overcurrent element for the main breaker. So I can go over here and click on that. Select this feeder as well. And now I can click this button, which is going to add what I've selected to the TCC. So let's click append. And you can see over here that now my relays are here. I have the 47E over here. and I have the 751 over here. Let's actually move these. And first, what I need to do is ungroup this. And now I can move my 751 relay over here. And I'm going to move my 47E relay all the way over here. And I just noticed over here that we don't have the CT for the high side. So let's go back into the one line. And I'm going to add this CT to my one line in the TCC plot. So that's this current transformer over here. So again, now I have my 751 relay over here, my 47E relay over here, and let me actually move these a little bit to the right. And so what happens here, if you notice that there's several curves here on the plot, is because when we modeled the relays, ETAP by default created some overcurrent curves, or rather it left them enabled. And so now they're showing up on the TCC. So what I can do over here is click on the relay, go to overcurrent relay, and then uncheck anything that I don't want to show up in this TCC. In this case, I just want to show the high side overcurrent curve. So I want to click OK. So now you see that some of them went away. Let's do the same thing for the 751. I'm just going to have one phase overcurrent element. So let's disable everything else. And for this example, I'm just going to do a 51, so an inverse time overcurrent element. And now we can click OK. And we can see that we have less curves now. However, you can see that we have the two curves all the way to the left over here. And that's because the default settings are just everything at minimum. So let me go back into the SEL-487E. In this case, I'm going to use a very inverse curve, which is a U3 curve in the SEL relays. This is a 5 amp CT, so the relay is also 5 amps. And just as a starting point, let's put 5 amps for the pickup and 3 for the time dial. And now you can see that the curve moved all the way up here. Let me move this tag over here. And let's do the same thing for the feeder relay. I'm going to use a US very inverse curve. It's a 5 amp relay. Let's put 5 for the pickup and 3 for the time dial. And again, now that moved that curve all the way over here. Let's move the tag over here. And so now let's actually run through the coordination study. The first thing that we need to do is to set our pickups. For the transformer, we have a 100 MVA transformer at 230 kV on the high side. So if we convert that to primary amps, that gives us that 100 MVA at 230 kV is equal to 251 amps. And I, of course, want to be some value above that for my overcurrent pickup. And for this example, I'm going to be using 50%. So I'm going to be at 150% of the full load amps of the transformer for the pickup of the overcurrent element on the high side of the transformer. So again, we're using this CT over here, the 400 to 5 CT. We're implementing an overcurrent function that uses the current flowing through that CT. And so if we have a 100 MVA transformer at 230 kV, that gives us that the full load amps of the transformer is equal to 251 amps. I'm going to multiply that times 1.5 to add some margin above that. And then, of course, I need to convert that to secondary amps from primary amps using the CT ratio that we have over here. So I'm going to divide that number, which is 376 amps primary. I'm going to divide that by 400 to 5. So divide that by 80. That gives me roughly 4.71. So basically all this means is that if I set my pickup to be 4.71, that's roughly 50% above the maximum rating of the transformer. And you can see that over here, 376.8 amps in primary terms. If you convert that at 230 kV to MVA, that's going to give you roughly 150 MVA, which again is 50% above the rating of the transformer. So let me go ahead and click OK. So now obviously that moved the curve for the relay all the way here to the right. And we have these damage curves over here for the transformer. I want to select my pickup such that I'm just below that damage curve. So again, this curve over here is the damage curve for the transformer. We selected the pickup of our overcurrent element for the transformer, but I'm going to move this curve up such that it just barely touches that curve. So essentially, I'm going to leave enough room downstream for coordination by moving this curve as close as I can to the damage curve of the transformer. One more thing that I want to do over here is to show the settings over here that I've selected. So to do that, you can double click on the background of the TCC, go here to devices, go to your relay, so the T1 relay, and I'm going to click on label and then label setting over here. Now when I click OK, I see all my settings that I selected over here. And I can actually just double click on that, and that takes me straight back to the settings for this relay. And so I'm going to round up the time dial to 7, hit OK. And again, all I want over here is to be just below this damage curve for the transformer. That's going to leave enough room downstream for the feeder relay to coordinate. So let me move that up over here. And now let's do the settings for the 751 relay. So we're going to go through the same process here. The pickup is going to be based on the maximum load for that feeder. In this case is 40 MVA. So we need to do the same process. 40 MVA at this voltage, which is 13.8 kV. That's roughly 1,673 amps. For the feeder, I'm just going to use a 25% margin. So I'm going to take that number, multiply it times 1.25. That gives me 2,091 amps. And then if I divide that by the CT ratio, which is 2,000 to 5 for this relay, so divide that number by 400, that gives me roughly 5.23 amps. And so I'm just going to round that number up to 5.3. So let's go back into the feeder, and my pickup for this relay is going to be 5.3. Again, what I did over here, and you can notice over here, the primary amps is 2120. If you take that number, 2120, multiply that times square root of 3, multiply that times 13.8 kV, that's going to give you the MVA that setting will allow. In this case, it's roughly 50 MVA, which is basically 40 MVA for the load, plus some margin above that. I use 25% for the margin. So now we have the two curves over here. I want to do the same thing for the feeder relay where I want to show the label. So again, you can click on the background, go to devices, go to your relay. So feeder 1 relay, go to label setting, and then hit OK. And that's going to show the settings down here. So one last thing that I want to show you is how to show the difference in time between these two curves. So you can click on this button over here, which gives you the time difference. Click on one curve, click on the other curve, and ETAP places this marker over here, which tells you the difference between those 2 points. So one thing that I like to do is to move this label to be at the same point as the marker itself. And so notice over here that as I'm moving this, and as the gap between the two curves increases, that number increases. Again, that number, this number over here, which right now is 1.48 seconds, is the difference in time between this point over here, so between one of the curves, and this point over here. So the point for the same current, but on the other curve. And what you want to do here is basically bring this such that this margin is at least 0.3 seconds for all conditions. So basically your lowest coordination time for any fault current level should be 0.3 seconds. So you can go all the way here to the end where both curves flatten out, and that's going to give you your absolute worst case. In this case, with the time dials that I've selected, that difference is 0.4 seconds. So what I can do is click on the curve for the feeder relay and just move this up a little bit until this difference becomes 0.3 seconds. And so actually what I found out is that if I set this time dial to 4, then that brings that coordination time to 0.302 seconds, which is a good coordination time. And so one thing that I want to point out here is that I tried to make these two curves as close to each other as I can, such that if there's anything downstream from the feeder relay that I need to coordinate with, there's going to be enough room for those devices to coordinate. So it's always nice to keep that margin tight, obviously with a 0.3 second minimum requirement, but keep the coordination time as close as you can, such that anything downstream from here can be coordinated as well. So in other words, if we had another relay down here somewhere in the feeder, or a recloser, for example, then this gives us room to put the curve maybe somewhere around here, such that it coordinates. Alright, so that's how you model protective relays and run protection coordination studies using the ETAP software. If you want to learn more about power system protection and control, check out our online courses where we go into these topics in a lot more detail. I'll leave a link to those courses in the description below. And as always, make sure to like the video if you found it helpful and subscribe to the channel for more videos about power engineering and power system protection and control. And we'll see you in the next one.